So we just watched that video. Okay, if you're watching the video online, I'll put a link to the video we just watched above it so you can watch that first. But we just watched our video. My first question to you is this. Of the video we just watched, what kind of things do you think we could measure? Height?
Volume.
Like, what do you mean volume?
Before and after.
Okay, before and after, that's good. What else could we measure from that video?
Distance.
What kind of distance?
Distance that goes like that.
So height, like she said, say again?
Velocity.
Velocity, how fast it comes out, yes. Guys, could I measure the number of Diet Coke bottles that we used? The number of Mentos that we used? Okay.
Number of scientists.
The number of scientists,
Number of minutes it takes for all of them.
Okay, the time, yeah. Okay, so today I'm going to choose what we're going to measure, if that's okay with you. You'll see why in a little while, okay? We're going to measure the number of Mentos and how high the Diet Coke went, okay? So the first thing I would like to do with you today is to create a scatter plot.
Okay.
So I'm pretty sure we're going to have to remember how to make a scatter plot. So go home. I mean, not actually home, but home on your calculator. Okay? We need a new document. So we can either press number 1 or enter, since that's highlighted right now. No, I don't want to save my old one. What kind of new document do I need?
5.
I need a list and spreadsheet. Okay? So I can actually press the number 4 or arrow down and press enter. Either one's fine. Okay? Think of the two values I just told you we're going to use. What were they?
Number of Mentos.
Number of Mentos and height. Right? How high they go. Which one of those two would be the independent variable? Which one would be the dependent variable? Which one's going to be X and which one's going to be Y?
The Mentos are independent.
The number of Mentos are independent. It depends on how high it is, depends on how many Mentos we have, right? Okay? So what are we going to do up here? What are we going to put up there?
I'm not sure.
Mentos. Okay? So I've got Mentos up there. So what are we going to put up here? Right here. Height. All right? H-E-I-G-H-T. Height. So now what do we need? Yeah, we need some data, don't we?
Yeah.
Okay? So let me tell you this. The data we're using today came from a physics class that was doing this experiment. Okay? They were put into groups, and different groups used different numbers of Mentos. Okay? There was a group that used 1 Mento. Wait, Mentos? It does Mentos. That's worse. Okay? So 1. There was a group that used 2 Mentos. There was a group that used 3 Mentos. Group that used 4. Guess what happened to 5? They knocked theirs over. That was probably Cole's group, right? Just teasing. Okay? So can we put 5 in here? They knocked it over so they couldn't measure the height. So if I'm going to put a data point, I need an X and a Y, right? So what do we need to do? We just got to skip 5, right? So there was a group that used 6, correct? Guess what happened to 7? Knocked it over. So then we're going to go to 8. Okay? That's all the groups there was. So let's go back over to height, and let's talk about group 1's height. Okay? The group that used 1 Mento, I don't know how to say that. It doesn't matter. Their stream of Diet Coke was 6 feet high. The group that used 2 Mentos, they had 11 feet. The group that used 3 Mentos had 14 feet. 4 Mentos used 16 feet. 6 Mentos was 20 feet. Yes, ma'am?
Wait. Geez, I messed up that. Okay, now 6, and then they had how many feet? 20?
Yes, ma'am?
Okay.
And 8 used 22 feet. So once again, we've done all this before, right? That was just a reminder, right? So how do I see the graph of this? I just entered. I need to control dock. That adds a page. What kind of page do I need to add? Good guess, though.
5.
5. Data and statistics.
Knew it.
Now remember, does yours look like mine right now?
Yes.
It might, but it might not, and that's okay, right? Remember, we've got to use our touchpad down here and make our x variable be what? The number of Mentos, right? So I choose Mentos. That was exciting. And then I need to make my y value be what? Height. Now, should ours look the same?
Yes.
Yes, it should. If it doesn't, it means one of us messed up on our values. And for the record, it was not me. Okay?
Oh.
So, what do you think, what do we normally do at this point? What do we need at this point?
A line.
We need a line or a shape, anyways, that goes to these points. And I need the equation of that, don't I? So do you remember how I would do that normally? Menu. Analyze. Regression, right? Wait, you can stay there, but I'm going to go back. Okay, hold on just a second. What shape is that?
That is like this.
You are right. You're showing me the right shape with your arm. That's good. What shape is that called? Yeah, it's not a parabola, because parabolas that we've talked about, like, are functional parabolas, and they only open up or down, right?
Oh, that's like when it's square.
Did somebody see that?
It's squared next to parabola.
No.
What did we just finish talking about? Square roots? Yeah? Okay, so if I go back to menu, analyze, regression, which one am I going to choose?
Linear.
Linear makes a line. Is a line and a square root function look the same? No, so I can't choose linear. Quadratic makes a parabola. Is this a parabola? No, I can't choose quadratic. Cubic means x to the third. Is x to the third and square root the same? No. Exponential means it's raised to a power that we don't know. We know the power. It's a half. Quartic means raised to the fourth power. So we have a problem, don't we? It's not there. Escape, escape, escape.
So now we're going to draw it ourselves.
We do. We have to draw it ourselves. Menu, analyze, plot function. So wait, basically what you're telling me is that we have to guess?
I think.
How do I feel about guessing? If I give you an equation on the board and I want you to solve it, how am I going to feel if you guess?
Not very good.
Not very good. I'll be irritated. We've just gone through all the steps, right? Of how to solve an equation. Is this the same kind of thing? No, it is not.
No.
I'm asking you to figure out the equation of a square root function that goes through as many points as possible. Is it okay to guess?
Yes.
Yeah. Okay. So first thing I'm going to do is I'm going to go ahead and put in the square root of x. Okay. Some of you guys are ahead of me. You be quiet for a second, okay? So I put in the square root of x. Is mine broken? What is this bottom left-hand corner point usually?
0.
It's the origin, right? 0, 0. Is that true on this graph? No, it's not, is it? X value is 0, but the Y value is what? From 14 to 20, there's a difference of 4, and there's 3 tick marks. So it's like 1 1/3. So we know for sure that it's not 0, don't we? God bless you. Okay? So it's not that mine's broken, it's that mine's too low. We can't see it, can we? So how do I make it steeper? Think about our transformation rules. How do I make this steeper? What's a negative going to do to it? It's going to reflect it, right? Reflect it across the x-axis. Is that what I want? No.
So you put like you say like 8 and then outside of it plus something.
So if we add something to it at the end, that'll slide it up or down. But that doesn't change how steep it is. What changes how steep it is? Like a vertical stretch. So we need a multiplier in front. So I need to move my tracker pad, my little thing, and I need to double click on it until my cursor shows up inside. And then let's put a multiplier in front. How about 2?
Sure. Not yet.
Well, I can see part of it. That's good, but that's not high enough. What should I try?
5. 7.
Delete. 5. Go closer. 10. Okay. 10.
Too much.
Okay, 10's too much. So where's the number that I'm looking for? No. That's not the question I ask. Where is the number I'm looking for?
Below 10.
Below 10 and
Above
5. So it's between 5 and 10. What number do you want me to try next?
8.
7.
8.
8.
7.5.
Oh.
There's 7.
8.
7 is too low. So now it's between 7 and 10, right?
9.
9.
What? No, I said 7.5.
It's 8.
It's 8.
9.
I said 8. You guys remember that?
It's too much.
9 is too much, so it's now between 7 and 9.
Could be anything.
Oh, wow.
7.8.
7.5.
Between 8
Oh,
and 10.
knew it.
Guys, whoever said we could only use whole numbers? You guys, because you don't want to deal with decimals and stuff. But could decimals get us closer than this?
Yes.
Maybe. Try some.
Do 8.2.
You do it.
I'm doing it. 7.9. I'm going to say...
She likes 7.9.
I got 7.3.
7.3?
Yeah.
I'm trying 8.
7.3.
7.569.
Is 7.3 okay?
No.
That's probably too low, right?
7.8.
7.6.
No, 7.8, but then it doesn't go...
7.9.
7.8.
7. Oh, it's just
How about we do like 7.83?
7.9.
Woo! I'm slowly getting there, guys. 7.84.
7.958.
So how are you deciding when to stop?
I don't know.
No clue.
What are we doing?
We're just trying to get them inside the little dots.
Yeah, we're guessing, right? We're guessing. We're trying to make our square root function be as close to as many of these dots as possible. So how are you deciding when to stop?
They're through all of them.
So are we going to find a number that goes right here that will go through all of these? No. Guys, this is real life data. Most of the time, real life data does not form a perfect curve or a perfect line. Okay? Most of the time we can use a regression like we tried to at the first, and that'll give us the best fit, like calculator-wise, mathematical-wise, that'll give us the line of best fit. Okay? Right now, we're guessing. So what I want you to do with your partner is decide what number, let's call this A for a second, this value, this multiplier value, because that's what we call it when we talk about transformations, right? You and your partner decide what you think is the best number. I'll give you 30 seconds.
7.94.
Okay, Nick.
We got it.
Alright, Ross. What'd you get?
It was like, it was fun, but took the 8 off.
Did you see that thing? Like,
Yeah.
no, Elizabeth didn't post it. Like JC Fortune post. It was like, I guess they had to read like this big book, and like she posted that thing of Ross where he's saying we were on a book.
All right, does everybody have an A value?
Yes.
Yes.
All right, what do you have for your A value?
I had 7.94.
7.94?
Me and Nick went with 7.9.
7.9? What do you got? 7.95? Anybody have anything different? 7.97? Okay. Anybody else?
We got 7.89.
So here's the deal. And this is going to bother you, some of you, and I understand that. Okay? But we're going to go on with the rest of the worksheet, knowing that some groups have chosen different numbers than other groups. And it's going to be okay. How did we decide when to stop? How did we decide when it was best? It was personal preference, wasn't it? You and your partner got together and decided, we think this is the best line. But some of you got different numbers, so some of your definition of like the best line is a little different. And for today, that is okay. Okay? I know some of you don't like that, but we're just going to go on. All right? So, the first question on this worksheet that you need to answer is, what characteristics of the graph indicate that a square root function might be a good model for the data? We already talked about that, but I want you to remind me. What do you think made a square root function the best model?
I'm sorry?
What characteristics of these points made us decide to go with the square root function?
The curve.
That looks like a square root function, right?
Pass them down.
It looks like it. Everybody okay with that? Is that a real mathematical answer?
No.
Not really. Okay? But on this worksheet right here, it says, where it says make a scatter plot, then it says what characteristics might indicate that the square root model is the good fit for the data. So you're just going to write, because it looks like a square root model.
Oh, so we already did most of this.
Yeah. We've done a lot of this.
So it's just the back that we have to do?
And the bottom. You're going to do the bottom of the front.
Oh, number 1?
Okay. Number 1, it says the rule for h of x can be written in the form h of x equals a times the square root of x, where a is a constant. Determine the value of a. Oh, yeah, you're right. We already did that.
Do you want to write down what we got?
I do. I want you to write down what you're choosing to use.
7.94.
Write the whole equation, though. It's even written for you right there. Write that whole equation.
I don't know where my equation went. It just
Do it again. Menu, analyze, plot regression. Plot function.
got 7.97. And that's your A. Oh, no. Like the whole...
This whole thing went away? Yeah, it does that sometimes. Okay, we ready to go on to number 2? Yes? All right, look at number 2. With your value for A, use your function to estimate the height of the spray for x equals 5 and x equals 7. Control doc. What does control doc do?
Add a page.
It's adding a page. What kind of page do we need?
The calculator.
Calculator page.
So 5.
So you got to use your equation. Where are we putting 5 in?
The square root.
Yeah, for x, right? So I'm not going to be able to do every single one of these, so I'll just put 7.9 because I think most people put something around that, right? Times the square root of 5. Now that's what I got. Did you get something close?
Yes.
Now, unless you use exactly 7.9, our answers are not the same, are they? Okay? So we could put, when x equals 5, y equals 17.6649, but we're too smart for that. Okay? We thought back to the problem. We thought to ourselves, man, when I look at this data on the front of this worksheet, it said 1 Mentos was 6 feet. 3 Mentos were 14 feet. Do you guys actually think that these physics students got one of those high-speed, like super slow-mo cameras that could like do frames at a time, and they inspected each frame to see exactly how high it went, and it went exactly 11 feet and exactly 16 feet? No, what'd they do? I mean, it was kind of a guess. They watched it, right? They said, what's the closest that it went, didn't they? So, do you think that we're going to put 17.6649?
No.
What are we going to put?
18.
We're going to put 18. So now here's what's weird. It's okay to be weird in math. I am. It's all right. Okay? Cameron, what did you put for your A?
7.94.
7.94. And what value did you get over here?
17.7544.
Wait, 17.7544. So what is Cameron going to put?
18.
Wait, I got a different A, and I'm going to put 18, and she got a different A, and she's also going to put 18?
Because the decimals above 5.
Oh, because we're estimating, aren't we?
Yeah.
We're estimating. No matter what we have for our A value, is there anybody in this room that's not going to put 18?
No.
No. Okay. What about 7? 7 Mentos. 7.9 times the square root of 7. What are you guys going to put based on your A value? 21. Now I have to argue with you some, and I didn't model it well for you a second ago. What is this again? 5 Mentos caused it to go 18. Oh, feet. Oh, we should probably put feet, shouldn't we? 18 feet. And what about this one?
21 feet.
21 feet. Okay? With your function, now we were just estimating things that were already, like they were supposed to be measured, but they weren't measured, right? So problem number 3 actually asks for a prediction, doesn't it? Predict how high the soda would shoot out of the bottle if you use 10 Mentos. Where are we putting the value for 10? Again into x, right? So 7.9 times the square root of 10.
Wait, we have to predict it first.
Okay, so predict it first.
26.
26? Anybody else want to predict it first?
Austin said 25.
Okay.
Oh.
25.
So what are we going to put as our answer?
25 feet.
25 feet. Good. All right, look at number 4. Using your function rules, set up and solve an inequality to determine the number of Mentos you would have to use for the spray to go at least 30 feet in the air. What's my inequality going to look like? Now, at this point, we're not guessing anymore, are we? This is something we actually have to set up and solve. So don't just shout out answers, please. Okay? Set up and solve an inequality to determine the number of Mentos. So first of all, I got to have my number of Mentos you would have to use for the spray to go at least 30 feet in the air. Here is the equation I've been using. You've been using something similar, right?
Mm-hmm.
Where's 30 go in this equation? Okay, h of x. So 30, 7.9 root x. Now, why didn't I put a sign in there? What does it ask for? An inequality. So I can't put an equal sign right there. I have to figure out the inequality. How does 30 relate to the number of Mentos? It has to be bigger than that? Because it says it's got to go at least 30 feet in the air?
So either greater than or equal to?
Greater than or equal.
So here's what's really confusing to some people. Here's the symbol I'm going to use. This has to be at least 30. Now, I know your whole life you've been taught that that is a less than sign. And while I agree with that, that's true when this is the exponent over here and this is the number over here. Or excuse me, not exponent, but variable. Okay? We have our variable on the right-hand side. So we have to say this number has to be greater than or equal to 30. It has to be at least 30. So the greater than part has to be on this side. The less than part has to be on this side. That confuses a lot of people. Are you one of them?
Yes.
Okay, me too. I have to think about it every time I write it. Where's my variable? This side has to be bigger. I have to make sure my greater than side is on that side and my less than side is on that side. You okay?
Mm-hmm.
For real? Okay, how do
Yes.
I solve this then?
Well, you subtract.
Well, we need to divide.
I need to
by
divide by 7.9
Okay.
because the 7.9 is being divided, right?
Yeah.
Or multiplied. Sorry.
30 divided by 7.9.
Now, you're using your A value, right? If you happen to be using 7.9, that's fine. But I'm going to put 30 divided by 7.9.
Are we rounding?
What did I write? Well, that's a good question. I can't yet because I'm not done. Okay? So what I got was the square root of x greater than or equal, less than or equal. I don't want to confuse you any more than you already are. 3.797. 47.
So now we have to square it.
Now I have to square it to get rid of the square root, right? So here, x, if I square that number, 144208.
Now what can we round it
I got
What?
4208. So have I solved my inequality?
to?
Yes, so mathematically this is my solution, right? Now I got to go back to the problem. And I have to think about this. Can I use 14.4208 Mentos?
You really can't.
No, you really can't. With Mentos, you have to be super, super careful even if you want to use 14 and a half, don't you?
So you're supposed to say
Because it would be kind of hard to do half of a Mentos, like exactly half, wouldn't it?
Yeah.
So what do you think we ought to do then?
Just use 15.
or 14.
So one of you said 15 and one of you said 14. So I want to show you something real quick. Okay? What would happen if I put 14 right here? 7.9 times the square root of 14.
Boom.
That is
And it
not
needs to be
enough.
greater
It has to be greater than 30, doesn't it? So, again, I hope I'm not completely confusing you, but we can't use 14, even though typical rounding rules means I would make this 14, right? Because this number right here is below 5. In the problem situation, if I use 14, it doesn't get to 30, and that's what I'm required to get to. So I need to say at least 15 Mentos. Okay? Now, that's how I'd write it in English. How would I write it in math?
15.
Greater than or equal.
So x is greater than or equal to 15?
Yeah.
Okay, you okay with that? All right, any questions so far?
Yeah.
Using your function rule, oh, sorry, we just did number 4. Number 5 is what I'm going to leave you to do by yourself. Okay? Using your function rule, set up and solve an equation. Notice it's asking for an equation to estimate the number of Mentos required for the spray to reach a height of 50 feet. Do you think it's reasonable? Why or why not? Okay? That's the one I'm going to leave for you to do by yourself. Hopefully for the end of class, because then you won't have any homework. Okay? Any questions?